Hello. I'm doing a recording batch, as you can see by my multiple tabs. Today I'm going to talk about my latest Python project. I got this data set here from San Francisco's fire department. Their calls for service, public safety, government. I think I went to Google dataset search and I searched fire and was looking for something exciting. This came up. So for my project, I'm doing an exploratory data analysis of emergency dispatch response times. How long does it take for your dispatcher to receive a call and then send out help? This data set came with a data dictionary, very extensive. Fortunately, I know Markdown well enough to put this into a table in a Jupyter notebook. What I'm going to be focused on today is receive date time, the date time and time of all calls received by the 911 dispatch center, and the dispatch date time, so when they actually dispatch a unit to the call. There's other timestamps in here. Entry, when they submit it into their system, response, when they show up, when they're on the scene. Not all emergencies, or not all calls to the fire department, I should say, require you to be on scene. So ultimately, I'm going to define dispatch time as the difference between dispatch timestamp here and the received call timestamp here. There's various other fields: call number, incident number, AVL, another timestamp, and those will all come into play later. So for Python, there's two libraries every data scientist should probably know. That's pandas and numpy. Since I'm going to be dealing with timestamps, I'm also importing the date time package just in case. I'm also importing my operating system so I can change my directory, pull and export from a specific folder in my computer. This is something I learned from school. Shut off your warnings. They look bad when you're submitting a code review. Warnings aren't the same as errors. You'll definitely see an error. Then I wanted to do some graphing. Wasn't sure what I was going to use, so I always use matplotlib and Seaborn. Those are my favorites. I'm sure there's others. Start off, change to my desktop, double check my desktop. Define my file here as the CSV. This was a huge CSV, like 2.5 gigs. And looking at the top rows here, you can see why it's such a big CSV. It's got 37 columns, if you saw earlier in the data dictionary. You'll actually have to go on GitHub and download this file if you want to see all 37 columns, but it gives you the preview here. Here I'm calling the column names. I do this when I'm coding. Probably should have left it out of the project. It helps me paste these into a text editor and edit and pull the columns that I need. I do the same thing when I'm working with SQL. Pull the column names and filter down. I'm looking at the shape of my data frame. You've got 6.5 million records, 37 rows. So I start with my data cleaning and transformation. The data set's huge, as I mentioned, so I'm going to drop my irrelevant columns. Available date time, entry date time, call dates, watch dates, response dates, etc. After doing this, I got it down to 14 rows that I believed would be relevant, at least for EDA. This will come back later, but these first three here are going to be unique IDs. Looks like I exported the top of the data frame to a CSV file. I was probably doing something in Excel. After data cleaning, I'm going to do some validation. I'm checking for duplicates. Don't want any double counting. So there can be a lot of calls, but As you can imagine, in an emergency, there may be multiple calls about the same incident. There's a fire, and then several people call the dispatch center about the same fire. I checked if there were any duplicates across the entire 18 rows of my new curated data frame. There weren't any. Print a duplicated data frame and then see if there's any values that are duplicated. But that's not quite good enough. As I mentioned earlier, there's going to be unique IDs. So, while none of the rows are unique, I'm going to do a subset on call number, unit ID, and incident number. First, I checked if any records had all three identical unique IDs. Then I did some permutations. So unit ID, incident number, unit ID, call number, incident number. All three combinations of what you could have. So for the first three, there were not any duplicates. But if you see here, call number and incident number, it does have duplicates in the set. Next, I counted the duplicates just using the shape argument, 0 for the first column, or rows. You can see I'm getting 3.5 million duplicates. So what's going on here? Well, I took that duplicate data set, and two call numbers are the same, the incident numbers are the same, the unit IDs were different. The alarms were the same. The call received timestamp and even the dispatch time were the exact same. All rows were the same except for unit ID and unit type. I went back to my table and it basically said that for unit ID, each unit here represents a different type of vehicle they send out. So this and this are redundant columns. Those are also what are causing duplicates. So if a call is received but multiple vehicle types are sent out, I don't want any double counting there. And just going across unit sequence and dispatch call. Yeah, you don't need to know about the unit sequence. Fire prevention district, that might be important. So yeah, as I just said, there's a dual classification for those separate vehicle types. Same call, same timestamps, separate unit IDs, and unit types. So I have to think about what I'm using this data set for. I'm doing an exploratory data analysis. So my aim is to remove duplicates. But there's multiple ways to think about it. If I choose to include all vehicles as part of the analysis, I'm going to have an imbalanced weighting when it comes to the actual calls themselves. And since what I'm worried about is the dispatch times, or the seconds, I don't want anything to be double counted. If I was worried about how long it takes each vehicle to get out, then I might. For this data set, I'm going to remove duplicates that have the same call number and incident number. So I'm removing anything with a unit identifier. Unit ID, unit type, unit sequence. So here's how you do that. Pandas is nice because you can chain your arguments. I made sure to drop my duplicates based on this subset. Always keep the first one. Doesn't matter which one you keep since I'm removing all unit identifiers. And then after that, I'm deleting anything with a unit in it. With pandas, I believe it's always going to do the left argument first. But I should probably avoid chaining in future projects since that isn't very reader-friendly to you right now. Next, I drop the unique identifiers since those are just random numbers. They aren't really going to help me with the data set. And you also run into I only know it as the curse of dimensionality. The more fields you have, the longer it's going to take your computer to process. So looking at the shape of my data frame, once I've dropped everything, we have just under 3 million records, 10 rows. Looking way better. Check out the columns that I have left here. And then for data validation, now I'm moving on to missing values. So first I check if there are any missing values in the data set. There are. So now I check which specific columns have missing values. df is NA, that's, will tell me if something has missing values, and sum aggregates them, telling you how many missing values there are for each column. For my call type and my timestamps, remember these two are going to be the focus of my analysis. There are no missing values. So since dispatch time is unaffected, I just took the L. You have some missing city data, some missing district data, which makes sense if you have missing city data. Same with the neighborhoods. Here, I use the info argument. I was looking at the fields and what data type they are. Right, because my timestamps came in as objects. It thinks they're like a string varchar character, but I do not want that. I want them to be timestamps. Pandas is nice about that. Pandas to datetime. I did look up the format on this, since we're looking at month, day, hour, minute, second, and I believe there was a nanosecond. It wasn't a nanosecond, it was AM or PM. Month, day, year, hour, minute, second, AM, PM. So after converting these to timestamps, take a look at my data frame again. You can see their data type, date time, 64 nanoseconds. That's looking good, that's what you want. For my data transformation, you want to create the dispatch time column in seconds. I want to see the difference from when the fire department receives the call versus when they actually dispatch people out. I named this difference in the seconds, dispatch seconds, and did the difference between these two timestamps. Here's where the date time package comes in, and I had that output as total seconds. If I look at the top of my data frame, you can see dispatch seconds gives you the seconds to 1 decimal point. Probably don't need that extra decimal point, but it's in there. Just looking at the dispatch seconds, I use describe. That gives you some exploratory measures. Count, you still see the 3 million records. The mean, the standard deviation, max and min. So check this out. We have a negative minimum. That's a lot too, 10 to the 5. For my purposes, I just removed any value that was sub-zero. In a future analysis, I would probably separate the minimum values, take a look at them, and see if they were just incorrectly calculated. The count of my negative records. Here again, you can see I'm doing a data frame on a data frame with conditional logic. Seconds less than 0. Dot shape, 0, give you the record or row count. 237 rows where I have negative data. Since I'm working with about just under 3 million records, I decided to remove these. Knew I had a reason. So I redefined the data frame, take a look at the top. Doesn't look like I lost anything. Doesn't look like anything broke. I export this CSV at this point. It's still huge. 3 million records. But now that it's clean, you can easily dump it into Tableau or Power BI. Make graphs a lot easier than you could in Python. I think these graphs were taking me like 10 minutes, and I only made 3. Next, I'm going to look at some qualitative variables. Looks like I only looked at the qualitative variables that didn't have missing values. So not that city data, not that neighborhood data, etc. Groups, I have call type, final disposition, and battalion. Here I'm using some conditional logic to count how many unique values there are for each field that I've defined in the groups here. N unique is a nice pandas function that gives you the count of unique values for each field. So for call type, I've got 33 unique values. Disposition, there's 15 of those. Battalions, looks like there's 12 of those in this data set. So I'm defining a data frame here, call type, EDA, exploratory data analysis for the call types, makes sense. I'm grouping by my call type, and then I'm looking at only the dispatch seconds, and then I do an aggregate function at the end here. The group by function in pandas, that always confuses me, but I've worked with it enough to know that this is how you aggregate. And this would have been much easier to do in SQL, which I actually did do in a later video. So yeah, after redefining this here, grouping by call type, checking out the seconds, I look at the top of this new data frame. You get your mean, median, sum, standard deviation, max, and min for the different call types. Did the same thing here for the call final disposition. Here you have the same exploratory data, mean, median, sum, standard deviation, max, min. Did it again for the battalion. Only look at the head of the data frame here. You can see the battalion numbers. Looks like they're already in order-ish. That's nice. Didn't have to put a sort values in there. You can see the mean, median, sum, standard deviation, max, min for each battalion. I thought sum might be important just so you could see which battalion in total is taking up the most call time. I'm trying to think about this from the fire department, the dispatch's point of view. Looks like I exported these group data frames as CSV files. So those all went to my desktop. Then here I'm using Seaborn's bar plot to find my data here. X would be the mean, Y is the call type, since those fields were included. And then palette muted, that's just a color preference. I was getting some wild colors. The chart's kind of cramped, but these charts, as I mentioned previously, were taking about 10 minutes to load. Next, I looked at the average dispatch time for the call final disposition. So medical advice, CHP, code 2 transports, multi-casualty incidents. That is kind of concerning. That also does make some sense. If you have multiple casualties, I'm sure you have to receive a lot of information before you can accurately dispatch everyone to where they need to be. Here again, I aggregated the means for each battalion. You can see Battalion 99, San Francisco, had the highest average dispatch time. Battalion 3E had the lowest. Interesting. This is a basic exploratory data analysis that I've run in Python. It's one of the latest projects I have right now. I'll definitely get more detailed in the future. Wanted to get started with my portfolio, and this seemed like a good project to start with. So, thanks for listening to me.